Okay, this video covers practice exam 2, number 11 through 20. All right, number 11 we're going to integrate x to the fourth minus 1 over x squared dx. So we want to divide x squared into each one of those. Divide x squared into x to the fourth, divide x squared into negative 1. So we'll rewrite this as x squared minus 1 over x squared is x to the minus 2 dx. So integrating that, we have 1/3 x cubed minus, and then you're going to have x to the minus 1. Okay, but we're going to need a minus out front, so we'll need a plus. Let's see if that works. So we'd have 3 times the x squared if we take a derivative, and then minus x to the minus 2. So we'll need a plus right there, and then plus c. So looking at our possible values, 1/3 x cubed minus 1 over x plus c, our plus 1 over x plus c, that's going to be d. Okay, so D is the one that works for number 11. Let's look at number 12. Number 12 is a little bit weird. It might be one that I might consider skipping, but in this case, I'm going to go ahead and work it. So we know that P prime of x is equal to Q of x. Okay, and we want to know what is negative 1 to 0 of Q of 4x dx. Okay, so this is actually a u substitution. We want to let u is equal to 4x, du is 1/4 dx, or excuse me, 4 dx. So 1/4 du is equal to dx. So we could rewrite this as 1/4 negative 1 to 0 of Q of u du. All right, and we know that P prime of x is equal to Q of x. Well, we're going to end up, if you just look at the answers, you know that 1/4 is going to be in the answer. And then you know it's going to be P of 0 and then P of negative 4, because we have to have, when we put negative 1 in there, 4 times negative 1 would be negative 4. Okay, so the only answer that will work in this case, without going through a lot of theory on how this works, is you know it's got to have 1/4 in it, so that's going to be C or D. And you know it's the top minus the bottom, so you need a minus, so that's just going to be answer C. Okay, so that's one you could probably narrow down and hopefully guess, just knowing how you evaluate an integral on that. But I'm not going to get into a lot of the theory on this one. Okay. Number 13. All right, 13 says water is leaking from a tank at a rate represented by f of t, whose graph is shown below. Which of the following is the best approximation of the total amount of water leaked from the tank between 1 and 3? Okay, and so we've got this kind of situation. This is f of t. This is at 3. And we'll say 1 is right here. And it looks like that's about 180 or so up here at the top. Okay, so what you need to get, if you want to know how much water leaked from the tank, you need to find the area under the curve between 1 and 3. That area. Well, how about if I just make it into a rectangle? And we're just going to guess that that's about 150, the top of that rectangle, where I've done the dashed line. Well, the total, if it were a rectangle, the total leaked is going to be 2 times 150, so 300 gallons. Well, we know it's less than 300 gallons because we have all of this section that's not under the curve. So what answer looking through would make the most sense? Well, A, 9.5 gallons wouldn't make any sense. B, 5 gallons. D doesn't because that's greater than 300. So the only one left is C, 175 gallons. So that's one you've got to understand. Total, when you're totaling something up, you are integrating or finding an area under the curve. If you missed the school bells, there you go. All right. That's number 13. That's one you're going to be able to knock out pretty quick if you understand the theory. Number 14 says we have f of x is equal to 5 cosine squared of pi minus x. What is f prime of pi over 2? Okay, so we've got to take the derivative. I'm going to rewrite f of x. So this is going to be a chain rule, and it's actually a 3-layer onion. Right? You might remember me talking about that way back in chapter 2. So we have 5 cosine pi minus x. I'm rewriting this and putting the exponent 2 like that. Same thing. Okay, so f prime of x is going to be 2 times 5 is 10 times the cosine of pi minus x times, okay, the derivative of the cosine of pi minus x. Well, that's going to be times negative sine pi minus x. That's the second layer of the onion. And then the third layer of the onion is what we call the blop in class, pi minus x. What's the derivative of pi minus x? Well, that's negative 1. So I've got a negative times a negative, so it's going to be 10 cosine pi minus x times sine pi minus x. All right, so what is f prime of pi over 2? That's going to be 10 cosine pi minus pi over 2 is pi over 2 times the sine of pi minus pi over 2 is pi over 2. Cosine of pi over 2 is just 0, so this whole thing, all that work to get a 0. So what's our option for 0? It's A. All right, all that work to get a 0, but hey, that's how it goes. And we did these exact kind of problems. So you do have to remember what the cosine and sine of pi over 2 is. All right. All right, halfway done with this section. So we have g of x is equal to 1 to x of 3t over t cubed plus 1 dt. What is g prime of 2? Okay, this is the fundamental theorem of calculus part 2. What you do is you plug in x, all right, if you want to get g prime, you plug in x, the upper limit, into t, and then multiply by the derivative of the upper limit, which in this case is 1. So g prime of x is going to be 3x over x cubed plus 1 times the derivative of x, which is just 1. Sometimes it's not. Sometimes you have, if it's x squared, then you'd be times 2x. So that's going to be, we're going to plug in 2, 3 times 2 over 2 cubed plus 1. That's going to be 6 over 9, which is 2/3. 2/3 is answer C. We can see I listed the answers here just in case I made a mistake. I could look at that every time. So, all right, 16. Let's see if I can fit 16. I'm not sure. I think this one should be a pretty fast one. 16 is going to take a little more time. So I'll go ahead and erase it. Okay, we have k to 2 of 2x minus 2 dx is equal to -3. What is a possible value of k? So what you have to do is just integrate this. We'll plug in k and solve for k. Okay, so integrating 2x minus 2, that's going to be x squared minus 2x. We're evaluating that from k to 2, and that's equal to -3. So let's plug in 2. We have 2 squared minus 2 times 2 minus k squared minus 2k, because we plugged the k in for x here, is equal to -3. 4 minus 4 is 0, so we'd have minus k squared, negative plus 2k is equal to -3. I'm going to shoot everything over to the right, and then we'll factor. 0 is equal to k squared minus 2k minus 3. Factor, so we got k, and we're going to say plus 3 minus 1 should do it. So k is going to equal -3 and 1. Let's see what our options are on number 16. Okay, 1 is an option, -3 is not an option, so 16, let's see, I did that wrong. So it's going to be, my bad, -3 plus 1. So the answers are, hopefully on the test you won't make that mistake. So the answers are 3 and -1, okay, and that's going to be D. Okay, so I'll give you a second to scratch out those mistakes. All right, number 17. All right, 17 says 0 to a of f of x dx is equal to negative a to 0 of f of x dx. What that's saying is that to the left, so if we were to graph this and we go -a, 0, and a, what it's saying is to the left, these two are symmetric. Okay, they look exactly the same, except one of them is going to be below the x-axis because it's negative, and one's going to be above the x-axis because it's positive. Okay, so looking at the values there, all right, the only one that fits is answer A. Okay, see how answer A goes like this? Okay, so they have the same area under the curve, it's just one's below the x-axis and one is above. Okay, so that's the only one that fits. All the others, the areas would be both positive or exactly the same, but this is the only one where you have a negative and a positive. It's the same value, but one is negative and one is positive. Okay, so that's it for 17. Number 18, we're going to skip. All right, the answer is A if you want to work that on your own, but I've gone through that solution. It's just not worth the explanation, not something that we really covered in class. So let's finish this up with 19 and 20. right, number 19. Given the equation v is equal to 1/3 pi r squared times 5 minus r, what is the instantaneous rate of change of v with respect to r at r equals 5? So you're looking for v prime of 5, instantaneous rate at 5. Okay, so we've got to take a derivative. So that's going to be dv dr. All right, I'm going to rewrite this before I do dv dr. I'm going to rewrite this. Let's go ahead and distribute those. So I'd have 5/3 pi r squared minus 1/3 pi r cubed. Okay, I could go ahead and maybe factor out a pi, factor out a r, all that. I'm just going to leave it like that, and we'll take the derivative that way. All right, so let's dv dr is equal to, okay, so that's going to be 2 times 5, so 10/3 pi r minus 3/3, so minus pi r squared. Okay, so let's plug in a 5 for that. For r, excuse me. So that's 10/3 times pi times 5 minus pi times 5 squared. All right, that's 50/3 pi minus 25 pi. Let's change this into 50/3 pi minus 75/3 pi. So that's going to be negative 25/3 times pi. I really hope that that is one of the answers. It is. Answer A. Okay, cool. You can do that. And you can, I think, probably do that in 2 minutes. Or less. Number 20. You guys are fast. Number 20 says, what is the slope of the tangent to the curve x cubed minus y squared equals 1? We want to know the slope at x equals 1. Okay, so we're also going to have to find the y value, all right, to get that. So if x is 1, okay, so if x is 1, y is going to be, so just rewriting this, we know that y squared is equal to x cubed minus 1. So if x is 1, we know that y is 0. When x is 1, y is 0, we're going to have to plug that in the end. Okay, so let's dx this thing. It's going to be 3x squared minus 2y dy dx is equal to bagel. Minus 2y dy dx is equal to minus 3x squared. So dy dx is equal to minus 3x squared over minus 2y. So that's 3x squared over 2y. So at x is 1 and y is 0, you would have 3/0. Okay, so the slope is undefined, which is answer D. So that completes the video for 11 through 20 on practice test 2. I'll continue on with more videos from this practice test in the coming days. So happy AP Calculus studying. Stay well out there.